There we go. Cuckoo. All right. Hey.
She was so sublime, super fine. She was never lying, strutting in the heels or her slides. Either way, eyes on her every single day, week, year. Everyone wondering how she does it with no fear.
Oh, come on.
Heaven sent, does it come within? Does it come run out? I don't know. She'll just have them running out and in. Man, they want to sin, talking deadly sin with Mrs. Lady. I don't understand why she hit them like.
Okay. Kind of loud though. Okay, so in the first week you will learn about the roles and responsibilities of the full stack developer. Okay. Okay, after completing the lesson items, you will be able to explain what backend, front end, and data stacks are. Which programming languages are tools? Tools. And these applications off. Look at the sound. Okay. Man, it really is bright over there. Okay, identify the role of a full stack developer and describe the components of the two types of in-tier architecture. Okay, week 2. Work on building the front end of an application. After completing the lesson items, you will be able to use common semantic tags. Okay, use Flex and CSS, create a test form with client-side validation. Use pseudo classes and manipulating DOMs. Okay, 3 is full stack with Django. Okay, some MySQLs. Okay. 7 viewers. What? Wow. Okay, cool. There's that one. There's that. Cool. All right. Let's see here. Week 4. This week you will explore different environments that web applications are deployed to. After completing the lesson items, you will be able to identify the different hosting solutions for web applications, grasp the key components of cloud computing environments, recognize the challenges of and solutions for scaling website applications, final projects. In the final week, you will apply the skills you gained from the course to implement code at each point of the full stack. After completing the project exercises, you will be able to connect the back end of an app to MySQL, setting up a booking API, and have an app display available booking time. Cool. That goals. Yep. Actively take notes. Okay. Slides in the course have everything installed and set up so you can start working with Django right away. You can get started with the terminal in VS Code. Oh. Also, Coursera has their own like embedded. Gotcha. Cool. All right.
Welcome to the Full Stack course. In this video, you'll learn what full stack development is, what a full stack developer does, and why it's an in-demand role in today's job market. You might find yourself wondering what stacks are. They are a combination of software, applications, and components you use to fix a problem or create a project with a certain development focus. For example, there's the front-end stack that's mostly focused on the user interface. Developers use different tools in programming languages, like HTML, CSS, and JavaScript, to build the front end of web and mobile applications. And together they are the front-end stack. On the other hand, you build the back end of a web application, which is mainly the app's core, with another set of programming languages and tools which include Python, Django, and DRF. And these comprise your back end stack. The back end stack also includes a data management system that consists of database applications to process data. This is generally referred to as the data stack and is part of the back end stack. Let's examine these three stacks in more detail. The back end stack has everything you need to create the back end of an application's core. That deals with business logic, workflows, and data. Back-end development includes programming languages like Python or JavaScript, frameworks like Django, and utilities like DRF, and also builds tools, databases, and caching applications. Let's shift the focus to the front end, which has two distinct parts, web and mobile. This stack includes everything you need to create a functional user interface of a web or mobile application that can communicate with the back end. To build the front end of a web application, you need to learn HTML, CSS, and CSS frameworks. You also need to know about client-side programming languages like JavaScript or TypeScript, and JavaScript frameworks like React. And lastly, you also have to be familiar with either iOS or Android development tools, or both, for mobile application development. Now let's move on to the data stack. One of the most crucial parts of every application is the data stack or tools you use to successfully store, process, and retrieve data. This stack contains SQL or NoSQL database engines, caching tools, and everything required to process data. In fact, MySQL, MariaDB, and PostgreSQL are some of the most widely used database engines you can learn to use for data stack. For caching, Redis is a popular and widely used solution. Finally, let's discuss the full stack, which is the end-to-end solution for an application. It contains everything you need to create the application's core or the backend, process the data, present it via APIs on web or mobile applications. A full stack developer is equally skilled in the backend, front end, and database stacks. Such a developer should have some essential DevOps skills to build and deploy an application to production, staging, and development servers. To be a full stack developer, you must learn everything that is required to create and deliver a functioning application.
Oh.
And you must also be familiar with a version control system like Git for full stack development. It takes time to be a successful full stack developer, so you'll have to be a little patient with yourself. But what exactly are a full stack developer's responsibilities? A typical full stack developer performs the following tasks: understand the complete project and take full ownership, select appropriate tools for developing the front end, back end, and database, create effective user interfaces for web and mobile applications, develop APIs, develop the back end of applications, store, process, and retrieve data from databases, create servers and manage them for development, staging, and production access, integrate with the CI/CD workflows, ensure the responsiveness of web applications, work together with the graphics team to bring their ideas to life, optimize applications for maximum performance, and make sure applications follow the best security practices. That's quite a lot of responsibilities, so you now understand why some patience is needed to learn all of these skills. But don't worry, with hard work and dedication, you'll get there. In this video, you learned about different stacks in the application development process. You also learned about full stack development and the role of a full stack developer. When you develop an application, it has different parts. There's the UI, backend, business logic, and database. These parts need to properly communicate with each other to make an application work. In this video, you will learn about some common architectures used in modern application development. Let's start with layers and tiers. In application development, you often hear the terms layers and tiers being used interchangeably. But there's a difference between them. As you learned earlier in the course, an application can have multiple parts, like the presentation part, the core of the application where the business logic stays, and the database. When these parts are in different places in the application infrastructure, like on different servers, but they still communicate with each other and function correctly, they are called tiers. Thus, layers are virtual separations of different parts of an application. Tiers are also different parts of an application, but they're physically separated in the application infrastructure. Now let's discuss N-tier architecture in two types, 3-tier and 4-tier architecture. In modern application development, there can be any number of tiers. When an application's architecture is split into multiple tiers, it's called an N-tier application. These days, 3-tier architecture is the most commonly used N-tier architecture. Some developers also use a 4-tier architecture when required. Let's say you developed a web application and the application is split into two distinct parts, the code with business logic that processes the data and the database to store the data. You host the application code on one server and the database on another. Since they are physically separated into two different servers, you can call them tiers. In this example, there are 2 tiers. So where's the third one? The third tier is the client computer or mobile, which is used to browse a web application or access the APIs. These clients are completely separate physical machines. So together, the client machine, your application server, and the database server make up a 3-tier architecture. In a 3-tier architecture, the client tier is called a presentation tier. Client machines are also called thin clients because they don't run business logic. They only communicate with your application and present the data. The tier that holds the application code or business logic is called the application tier. And finally, the tier that deals with data is called the data tier. So the 3 tiers are presentation, application, and data tiers. Let's move on to the 4-tier architecture. In a web application with a 4-tier architecture, a 4th tier is included called the delivery tier. This delivery tier deals with caching and delivering the front-end assets to the client. For example, like a content delivery network or CDN. CDN providers have many servers across the world for better content delivery. They store your web application's HTML, CSS, JavaScript, and images and deliver them to the client from the nearest server. Because CDN servers are physically separated from your application and data tiers, they're seen as another tier, the delivery tier. This is just one example of a 4-tier web application, and these applications can be very different from one another depending on their purpose. Like, for example, financial or enterprise applications that have different needs. There are several benefits to an N-tier architecture. Let's examine some of them now. When the application is divided into multiple tiers, it becomes easier to secure and scale the application. And fixing problems or adding new features becomes more manageable because each tier is separate and works independently. Thus, the application development process becomes more efficient when you use an N-tier architecture for your application. In this video, you learned about the difference between layers and tiers. You also learned about the popular N-tier architecture and how to use it to create a 3 or 4-tier architecture for your web applications.
Recap. Okay. Okay. All right. Let's keep going. Okay, the data is processed by business logic, saved or served from the database, and the response is sent back to the client. Doop, doop, doop. Yeah. Okay.
tell you what you mean to me. Chemistry, intimate memories. Every time I give you all my energy, emphasis, never sleep. Never sleep. Say you have me. Oh, taste and see. Hope you don't sleep on me. I got good and plenty. I've seen all this before in my mind. All I ask is take your sweet time. Roam around and see what you find. Long as I can call it mine. Oh, I can give you everything you dream about. Let me be the one to reassure you that you'll never run out. Just say oh, taste and see. I hope you don't sleep on me. I got good and plenty, Detroit, trying to get that.
Many of the activities you do every day can progress through the course. When you eat at a restaurant, there are often many of the best paid jobs in the IT industry.
I'm in Detroit with Khadijah, flights and feelings rolling real. It's organic, how we speed through midnight moments pouring deep.
Have you ever wondered how your app loads up so fast or how to help power that in the future?
From finding love in the waveform, is you someone to wait for? Is he trying to stay on the ride, or is he trying to leave the vibe? Take it to the altar if you want to slide. Renaissance trap, baby, make a ride. Is he trying to fall for the night, or is he trying to fall for life? City full of people, you got options, right? Baskin Robbins, baby, what you want to try?
Okay. Uh,
Hello and welcome. Did you ever find yourself searching for something online? How long did it take to get a response from your search? You search for something and you get a response back in no time. That's really something, isn't it? But did you ever think about how it all happens? In this video, I will guide you through the basics of how the internet works. Let's start at the beginning. You open your favorite app on your device and you're instantly connected to the world. This is all made possible because two devices connect and communicate via a wired or wireless connection, forming something called a network. You can connect multiple devices to this network, but this becomes very complicated very quickly as each device needs to connect to every other device to communicate effectively. This problem is solved by something called the internet connects the entire world. Have you ever had a video call with someone on another continent? That video data traveled through large undersea cables connecting the world's networks, and these cables can transfer huge volumes of data per second. There are a lot more technical details that go into making the internet possible, but this is the main idea. Hopefully, this gave you the big picture of how the internet works. A server is a computer that runs applications and services, ranging from websites to instant messaging. It's called a server because it provides a service to another computer and its user, also known as the client. It's typically stored in something called a data center with hundreds or thousands of other servers, all running different services connected to the internet. There are many different systems in data centers to ensure that servers have continuous power, continuous internet connection, and are kept cool 24 hours per day. Did you know that there are data centers located all around the world? Many websites use these to allow you to access your content quickly from the data center nearest to you. The data center servers are built based on the server's purpose. For example, if the server is only to be used for storing images, it might have a lot of hard drive space, whereas a server computing complex calculations might need a fast processor and a lot of memory. This is usually referred to as the server hardware, the physical components of a server. Once the server hardware is installed in the data center, a piece of code can now run. The code that runs on the hardware is commonly known as software. One way I like to remember this is to think of hardware as something you can physically touch and is difficult to change, as you need to physically replace components. Software is soft or easy to change. You just replace the code running on the server. The services a server can run can vary, but in this video, you will learn about a type of server software known as a web server. A web server has many functions, which includes website storage and administration, data storage, security, and managing email. Another primary function is to handle something known as a web request. When you open a browser on your device and type the name of the website, it's the job of the web server to send you back to that website's content. This process is known as the request-response cycle, and you will learn more about it later. Web servers are also designed to respond to thousands of requests from clients per second. In this video, you learned about web servers and how they consist of hardware and software. You also learned that one of the primary roles of a web server is to respond to web requests from the client.
Why read only?
You may have heard the terms web pages and websites. But what's the difference? A web page is a document that displays images, text, videos, and other content in the web browser.
To
A
YouTube?
website is a collection of web pages that link together. You've likely visited many websites this week. In fact, you're watching a video on one right now. Let's explore an example when you visit your favorite encyclopedia website. When you arrive at the homepage,
Appreciate
it
the
contains
follow,
many links to different
unique
articles.
sailor.
Clicking on one of those links brings you to a new web page article. And that article links to even more articles and other web pages. If all these web pages have a similar address in the web browser's address bar, it can be safe to assume that they belong to the same website. However, the links on the page do not all have to link to the same website. They can also link to other websites. For example, when you visit your favorite search engine and search for a phrase, the search results are a list of links to other websites. Did you know that as I'm talking to you, thousands of websites are being launched to the internet? Every day, hundreds of thousands of websites are launched. To put things into perspective, the Great Pyramid of Giza has 2.3 million blocks of stone. So think about it. In 1 week, there are as many new web pages as stones in the Great Pyramid. With current internet speeds, it would take 3 million years to download all the web pages on the internet. And all of these billions of varied web pages rely on the same core technologies. Most people interact with websites in some form daily, but few know how a web page actually works. I mean, what's it made up of? And just how does that web page get from the web server to what you see on your screen or device? Well, let's explore that now. In its most basic form, a web page is just a text document. You can open and edit with any text editor. But developers usually use more sophisticated tools for working with web pages. If you want to work with a web page, you need to know about 3 technologies and understand how they interact. They are HTML, CSS, and JavaScript. HTML structures the content you see. CSS controls the colors and style, and JavaScript is responsible for the user interaction. As a web developer, you will work with these technologies every day and understand how they work together. I always like to imagine it like this. Think of a shop. HTML is the actual building, the structure. CSS is the interior decoration and landscaping outside, and JavaScript is just like the business, the services offered, and the people coming in and out. Let me give you a brief overview of each of these technologies now. HTML stands for Hypertext Markup Language. It works by using something called markup tags. These tags describe the content that is displayed in the browser window. This content can be things like headings, paragraphs, images, and even multimedia elements such as audio and video. The way HTML describes the content is known as markup. CSS is short for cascading style sheets and adds visual enhancements like colors and layout to the web page. This is commonly known as styling. It works by enhancing the HTML elements and telling them how to display. Have you ever noticed a friend change their color or style of their hair? Well, your friend's hair is like the HTML, and the color and style is CSS. The last technology is JavaScript, which is a programming language built into the browser. JavaScript provides web developers with tools for interactivity, data processing, control, and action. Have you ever tried to log into a website only to be told that the information you provided was incorrect, or browsed your favorite video streaming site and seen content update in real time? Well, that's JavaScript in action. JavaScript is the powerhouse of a web page. It has the ability to manipulate the content that you see on the screen as you interact with it. In fact, without JavaScript, websites would be kind of boring and very limited in terms of what you can do. Okay, you now know about the essential technologies a web page contains, but how exactly does this code get translated to display the content that you see on your screen? When a copy of that web page is sent from the web server to your browser, each line of code is processed in sequential order from first to last. As each line is interpreted, the browser creates the building blocks, which is the visual representation you see on the screen. This creation process is known as page rendering. The response from the web server must be a complete web page in order to fulfill the request to show the page in the browser. You will learn more about page rendering from the additional reading at the end of this lesson. And there you have it. You now have joined the exclusive group of developers who know how a web page works. You learned about the technologies that make up a web page and how they interact with each other. You also learned that the page is rendered by the web browser to display what the end user sees on the screen. In the time since you started watching this video, another few thousand websites launched. Every one of them is another example of modern web developers building and adding to the ever-growing internet. Are you ready to become one of them? You use a web browser every day on your devices, and you probably have one open right now watching this video. But do you really know how they work? In this video, you will learn what a web browser is and how it receives and displays content. Let's get started. A web browser, or browser for short, is a software application that you use to browse the World Wide Web. It works by sending a request to a web server and then receives a response containing the content that is to be displayed on the screen of your device. Once the browser is open on your device, there is the address bar where you input the address of the website that you want to visit. The address is commonly known as the Uniform Resource Locator, or URL for short. The URL contains the protocol, or the HTTP, the domain name, usually the name of the website, and the file path, or the path to the page that is displayed. When you make a request using this URL, the browser and server communicate using a protocol known as the Hypertext Transfer Protocol, or HTTP. Once the web browser receives the content, it displays it on the screen of your device. This exchange of information is made possible by something known as the request-response cycle. Now, let me demonstrate this using an example many of us are familiar with, searching the web. First, you open a web browser, which is a software application. Next, you type the name of your favorite search engine. The name you type contains something called a domain name. Then, when you press enter, the web browser sends a request across a network and connects to another computer on the internet called a web server. The web server is a special type of computer that allows other computers to make requests for data. The web server responds by sending a web page back to the browser. Once the browser receives all the response information, the search engine web page is made visible. The web page is a coded document that is rendered by the browser and then presented visually to you, the end user. Now that the search engine web page is loaded in the browser, you interact with that page to search for what you want to find. For example, type restaurants near me in the search bar and press the search button. Once again, the browser prepares and sends a request to the same search engine web server. This time, the request contains the added instructions to search for the phrase restaurants near me. The search engine web server processes the request by taking the keyword and using it to find the requested data. This data is stored in something called a database, which is connected to the web server. The web server then picks up that data and sends it back to the browser. When the web browser receives the full response from the web server, it again renders a visible web page with links to some restaurants, a map showing nearby locations, and more related information such as reviews, lists, and even reservations. Success, and all made possible by computers having a conversation. You have now gained an insight into how the request-response cycle works, and this web request cycle is very similar for a number of other activities we do online, be it chatting with friends, watching our favorite movie, or sharing files with our work colleagues. That is just a brief summary of how the internet works. The next time you search for something online, think of all the steps and data that gets exchanged to complete your request. You use a web browser every day on your devices. If the browser receives the content, it displays it on the screen of your device. This exchange of information is exchanged to complete your request. Okay, so by now, you know that websites and files are stored on web servers located in data centers. But what if you wanted to create your own website? Do you really need your own data center with specialized hardware and software? Thankfully, the answer is no. And developers can launch websites to the internet using something known as web hosting. Web hosting is a service where you place your website and files on the hosting company's web server. You're essentially renting this space in return for stable and secure storage. And you don't need to be a company to use a web host. Individuals can rent space too. In this video, you will learn about the different types of web hosting services that you can use for your websites and web applications. First, let me share with you some of the different hosting options available. These can include shared hosting, virtual private hosting, dedicated hosting, and cloud hosting. Let's explore each of these hosting types in a little more detail now. The cheapest form of web hosting is known as shared hosting. You pay for a location on a web server containing many web hosting accounts with shared hosting. This means that you also share the server's processing power, memory, and bandwidth with other websites that might slow your performance. This option is best for a small website with a small number of visitors. Many developers also use this as a low-cost sandbox environment to practice deploying or hosting their personal websites. Some companies offer free shared hosting, but with limitations, and often have advertisements embedded in the web pages. Sites with more considerable demands use virtual private servers, or VPS. A VPS is a virtual server with dedicated CPU, memory, and bandwidth resources. It will be running on a hardware server with other VPS instances, but as the resources are fixed per VPS instance, your website is unlikely to be impacted by the performance of other VPS instances. A VPS instance will be more expensive than shared hosting. The next option up is to use dedicated hosting. This will be a hardware server that is dedicated to you only. All hardware CPU, memory, and bandwidth resources are yours to use. Generally, this option is more expensive than a VPS hosting. The last type of web hosting is something you may have heard of. Cloud hosting and the cloud has grown in popularity over the last decade and is often mentioned in various news and services you use. With cloud hosting, your website is run in something called a cloud environment, which spans across multiple physical and virtual servers. If a physical or virtual server fails, your website will run on a different server and stay online. The main advantage of cloud hosting is that you can use as many resources as you need without hardware limitations. However, you pay based on resource use. For example, if you transfer a file from the cloud to a web browser, you'll pay for the bandwidth used for that transfer at a fractional cent cost per megabyte. While this can quickly become more expensive, it allows websites and web applications to scale their cost as popularity grows. This is how many of the major web applications operate. In this video, you learned about web hosting and the different hosting options available to individuals and companies. Soon you will build your very first website. Are you excited to get it hosted so you can share it with the world? For more information on web hosting and services, please see the additional reading at the end of this lesson.
Hell yeah. What? Let's go.
Email is a common communication method that we all know about, but before it existed, the alternative was to send mail to one another through the postal system. There is a surprising parallel between the postal system and how the computer sends and receives data across the internet every day. Let's compare how they both work. Data sent across the internet is quite an important part of our everyday lives, and it wouldn't be possible without Internet Protocol addresses, or IP addresses. A useful way to think of IP addresses is that they function much like addresses in a postal system that make it possible for packets of information to be delivered to you. And, like with the postal system, things can go wrong. But let's first go over how things work before we think about how they can go wrong. In this video, you will learn what IP addresses are and explore how computers send data across the internet. You previously learned how computers connect to each other to form networks and how these networks connect to each other to form the internet. When you send data between computers across the internet, a common way of understanding this is that the computers are the destinations that request and receive the data, and the networks are the routes that the data travels across. What makes that possible is the Internet Protocol. Version 4 and version 6 are currently the two most widely used standards of Internet Protocol. Think of the old-fashioned postal system again. When you send a letter to a friend, you need their address, otherwise they won't receive your letter. Computers work in a similar way. Every computer on a network is assigned an IP address. In Protocol version 4, an IP address contains 4 octets separated by periods or dots. For example, 192.0.2.235. In Protocol version 6, an IP address contains 8 groups of hexadecimal digits separated by a colon. When you send data across a network, you send the data as a series of messages called IP packets, also known as datagrams. At a high level, IP packets contain a header and a payload, which is the data. Think of that old-fashioned postal system again. When you send a letter, you not only include the recipient's address, but also your own address, in case a return location is needed. IP packets are the same. They include the destination IP address and source IP address. These addresses are in the header along with some additional information to help deliver the packet. And the payload contains the data of the packet and some of the other protocols, which we'll cover in a moment. Earlier, I mentioned that things can go wrong with a postal system. When sending multiple letters to a friend, it's possible they may arrive out of order. It's possible that a package will get damaged, or if you're really unlucky, a letter could get lost. These issues can happen to IP packets too. They can arrive out of order, become damaged or corrupted during transit, or be dropped or lost during transit. To solve these problems, the payload part of the packets contains other protocols too. You can think of them as another message inside the payload of the IP packet. The two most common protocols are the Transmission Control Protocol, referred to as TCP, and the User Datagram Protocol, also known as UDP. TCP can solve all three of the previously mentioned issues, but at the cost of a small delay when sending the data. This protocol is used for sending the data that must arrive correctly and in order, such as a text or image files. UDP solves the corrupt packet issue, but packets can still arrive out of order or not arrive at all. This protocol is used for sending data that can tolerate some data loss, such as voice calls or live video streaming. Both of these protocols contain payloads that contain further protocols inside of them. And there you have it. The internet uses internet protocols, much like an old-fashioned postal system. These protocols can help to make sure that data arrives in order, does not become corrupted or lost or dropped during transit. Now you're able to explain how IP addresses work and how computers send data across the internet. Have you ever noticed the lock icon beside the URL in your web browser? This means that HTTPS, the secure version of HTTP, is being used. HTTP is a core operational protocol of the World Wide Web. It is what enables your web browser to communicate with the web server that hosts a website. HTTP is the communication protocol you use whenever you browse the web. HTTP stands for Hypertext Transfer Protocol. It is a protocol used for transferring web resources such as HTML documents, images, styles, and other files. HTTP is a request-response-based protocol. A web browser or client sends an HTTP request to a server, and the web server sends the HTTP response back to the browser. Next, let's start exploring the makeup of an HTTP request. An HTTP request consists of a method, path, version, and headers. The HTTP method describes the type of action that the client wants to perform. The primary or the most commonly used HTTP methods are get, post, put, and delete. The get method is used to retrieve information from the given server. The post request is used to send data to the server. The put method updates whatever currently exists on the web server with something else, and the delete method removes the resource. The path is the representation of where the resource is stored on the web server. For example, if you wanted to request an image from a page in a website, then the URL in the address bar would need to contain the full path to that particular file on the web server, such as example.com/images/image.jpg. There are multiple versions of the HTTP protocol. I won't explore these right now, but I want you to be aware that versions 1.1 and 2.0 are the most used. Finally, there are the headers. Headers contain additional information about the request and the client that is making the request. And for certain request methods, the request will also contain a body of content that the client is sending. Now, let's cover some details about the makeup of an HTTP response. HTTP responses follow a format similar to the request format. Following the header, the response will optionally contain a message body consisting of the response content, such as the HTML document, the image file, and so forth. HTTP status codes contained within the header indicate if the HTTP request successfully completed. The code values are in the range of 100 to 599 and are grouped by purpose. The status message is a text representation of the status code. During your web browsing, have you ever encountered pages that display 404 error not found or 500 errors, server is not responding? These are HTTP status codes. I want to briefly explain to you about the status codes and their grouping. There are 5 groups of status codes. They are grouped by the first digit of the error number. Informational is grouped from 100 to 199. Successful responses are grouped from 200 to 299. Redirection message are from 300 to 399. Client error responses range from 400 to 499, and server error responses are from 500 to 599. Information responses are provisional responses sent by the server. These responses are interim, before the actual response. The most common information response is 100 continue, which indicates that the web client should continue the request or ignore the response if the request is already finished. Successful responses indicate that the request was successfully processed by the web server, with the most common success response being 200 OK. You're receiving these responses every day when you receive content successfully from a website. The meaning of OK depends on the HTTP method. If the method is GET, it means that the resource was found and is included in the body of the HTTP response. If it's POST, it means that the resource was successfully transmitted to the web server. And if it's PUT, the resource was successfully transmitted to the web server. Finally, if the method is delete, it means the resource was deleted. Redirection responses indicate to the web client that the requested resource has been moved to a different path. The most common response codes used are 301 moved permanently and 302 found. The difference between the redirection messages 301 and 302 is that 302 indicates a temporary redirection. The resource has been temporarily moved. When web browsers receive these responses, they will automatically submit the request for the resource at the new path. Client error responses indicate that the request contained bad syntax or content and cannot be processed by the web server. The most common codes used are 400 is used where the web browser or client submitted bad data to the web server. 401 is used to indicate that the user must log into an account before the request can be processed. 403 is used to indicate the request was valid, but that the web server is refusing to process it. This is often used to indicate that a user does not have sufficient permissions to execute an action in a web application. 404 is used to indicate that the request resource was not found on the web server. Server error responses indicate that a failure occurred on the web server while trying to process the request. The most common code used is 500 internal server error, which is a generic error status indicating that the server failed to process the request. Now, have you ever bought something online and needed to enter your credit card information? You wouldn't want someone else to get this information from the HTTP request, right? This is where HTTPS is involved. HTTPS is the secure version of HTTP. It is used for secure communication between two computers so that nobody else can see the information being sent and received. It does this by using something called encryption. We won't cover encryption right now. Like in HTTP, the requests and responses still behave in the same way and have the same content. The big difference is that before the content is sent, it is turned into a secret code. Only the other computer can turn the secret code back into its original content. If someone else was to look at the code, it wouldn't be understandable. You use HTTPS every day. This is the lock icon you see beside the URL in your web browser. Okay, before I finish, I want to leave you with a brief summary of HTTP. Firstly, it is a protocol used by web clients and web servers. It works to transfer web resources such as HTML files and is the foundation of any data exchanges on the web. Also, remember that by using HTTPS, we send the information securely. Requests are sent by the client, usually a web browser, and the server replies with responses, which may be the return of an image or an HTML page. HTTP requests have a syntax that includes method, path, versions, and headers. HTTP responses follow a similar format to the request, and HTTP status codes indicate whether the HTTP request successfully completed. The status code is a 3-digit number that corresponds with groups representing different types of results. Well, now you know how the HTTP protocol request and response cycle works. You know about its methods and the elements that make up an HTTP request. Good job.
What's your flavor? Tell me what's your flavor. It's a wing, dang, dang. What's that symbol slang? Going island hang. Tell me what's your flavor. I think she want me for my loot. I think she wanna get some food.
The web pages you visit every day are based on 3 core technologies: HTML, CSS, and JavaScript. Together, they enable you to create web pages and applications so you can offer any content you have seen online. In this video, I will demonstrate 2 examples you can create using these technologies. This is to help you understand how they interact with one another. Don't worry, you won't need to deal with the details of the 3 languages just yet. In the first example, I'm building a web page that displays a digital clock. It shows the hour, minutes, and seconds. The time is updated every second. I will work with 3 files, an HTML, a CSS, and a JavaScript file, and you will explore the purpose of each one of them. To create the clock element, let's first define our HTML code in a file called clock.html. The HTML code has an element that describes the content in hours, minutes, and seconds. If I only use the HTML file, the content would be shown without any style, positioning, or sizing, just simply as a display of 6 zeros representing time in the format of hours, minutes, seconds. To apply styles to the HTML element, the HTML code references a CSS file called styles.css. The web browser retrieves the styles.css file and processes it. The CSS code provides styling for the clock. It tells the browser the position, size, color, background, and font type and size of each element on the screen. With that information, the browser updates the content and the sequence of zeros and colons now display a digital clock. Finally, we need to ensure the clock updates with the correct time. This is where JavaScript comes in. The HTML references a JavaScript file called clock.js. The browser will retrieve clock.js and process it. The JavaScript file contains code that every second updates the content of the hour, minute, and second elements. With the 3 files created and linked together, your clock is fully functional. The clock example demonstrates JavaScript dynamically updating content. JavaScript can also be used for interaction. The next example demonstrates how JavaScript can be used interactively. It's a web page that plays a video. Below the video, there is a button that plays or pauses the video. The button contains a play icon. My HTML page describes the content, which is the video element and the play button element. The HTML code references a CSS file that the browser retrieves. It applies the styling to the video and button. The code in the HTML file also references a JavaScript file. The browser will retrieve the video player.js file and process it. In our example, the code in the JavaScript file performs 4 actions. Firstly, it registers a listener on the button that will execute some code when the button is clicked. The second function is that when the code runs, it checks the current state of the video. The result of that check is, if the video is currently stopped, it begins playing the video and changes the button's icon to a stop icon. Or, if the video is currently playing, it stops playing the video and changes the button's icon to a play icon. Using the 3 files, you create a fully interactive video player. A summary of your functioning video player application is, when the user first sees the page, the video will be stopped by default. When they click the play button, the button will change to a stop icon and the video will begin playing. When they click the button again, it will change back to a play button and the video will stop playing. I hope those examples give you an idea of how the 3 core files link and work together. In both the clock and video examples, the HTML file references the CSS and the JavaScript files. The CSS file is called on to format and style your application, and the code in the JavaScript file implements the core functions of the app and user interactivity. When you're doing something online, you are likely to encounter web pages, websites, and web applications. But how do they differ? As a developer, how do you decide which one to create? Let's explore the main features of each one. A typical web page is one single page that consists of HTML, CSS, and JavaScript. It displays images, text, videos, and other content in the web browser. If a web page is one single page, then a website is a collection of web pages that link together under one domain name. You've likely visited many websites this week. You know when you visit your favorite encyclopedia website and the homepage has a lot of links to different articles. Clicking on one of those links brings you to an article on a new web page. And that article links to more articles on other web pages. Well, since all of these web pages exist under the same domain name, they are a website. The technical term for a link you click on is a hyperlink. This is because they link to hypertext content. Remember that HTML is hypertext, markup language. However, links themselves don't have to link to the same website. They can also link to other websites. For example, when you go to your favorite search engine and search for a phrase, the search results are a list of links to other websites. You'll explore more about hyperlinks later. By now, you should probably know the difference between a web page and a website. But what about a web application? This is where the definitions get a little more blurred. The terms website and web application are often used interchangeably. The key difference between a website and web application is the level of interactivity and dynamic content. The easy way to remember this is that a website is more informative and a web application is more interactive. Think of ordering food online. Let's say you would like to order some food and you go to your favorite site. The browser then displays a web page. You select some food from the menu and submit your order. Compare this to, for example, a company website that displays information about themselves and the services they provide. In the food ordering example, the content displayed is specific to your user account and location. The web application displays content based on the user's input and interaction. Whereas with the company website, the user simply views the content, and this content is the same for everyone who visits the website. You should now be able to distinguish between web pages, websites, and web applications. You know that web pages at a particular domain make up a website, and that the key difference between websites and web applications is the level of interactivity and dynamic content.
man commute. I think she wanna 15 minutes of fame, or 15 minutes away from finding love in the way form. Is you someone to wait for? Is he trying to stay on the ride, or is he trying to leave the vibe? Take you to the hotel if you wanna slide. Renaissance drive, baby, make a ride. Is he trying to fall for the night, or is he trying to fall for life? City full of people, you got options, right? Baskin Robbins, baby, where you wanna drive? What's your flavor? Tell me what's your flavor? What's your flavor? Tell me what's your flavor? It's a wing, bang, bang. What's that simple slang? Growing island hang.
If a car breaks down, you can open the hood to examine that engine and to find out what's gone wrong. As a developer, if your front end isn't working as expected, you can also open the hood to check what's going wrong. In fact, it's not just your own code that you can investigate. How about viewing other people's code? By the end of this video, you'll be able to access and make use of common web browser developer tools. Most web browsers come equipped with a set of developer tools that allow developers to inspect their HTML, CSS, and JavaScript code. Also, to trace HTTP requests to the web server, investigate performance issues, and review web page security. Let's find out more by exploring the homepage of the Little Lemon Cafe. To begin, I've just opened the Little Lemon Cafe's webpage on my Chrome browser. On the homepage, I can view their menu, but I want to explore the HTML structure of this menu. To do that, I need to open the developer tools. To open the developer tools in Chrome, press the F12 key on your keyboard for PC or Command-Option-J on Mac. Alternatively, you can right-click on the webpage and select Inspect. There are various tabs on the top row of developer tools that provide different functionality. In this video, I'll give you a high-level explanation of some of the most used tools. First, let's open the Console tab. This tab outputs JavaScript logs and errors from your web application. The Sources tab shows all content resolved for the current page. It includes HTML, CSS, JavaScript images, and videos. With the Network tab, you can inspect the timeline and details of HTTP requests and responses for the web page. The Performance tab shows what the web browser is doing over time. It is useful if your web application is running slow because you can pinpoint the functions that are taking the most time. The Memory tab displays the parts of your code that are consuming the most resources. Finally, let's check the most used tab, the Elements tab. You can use this tab to inspect the document's HTML elements and their properties. For example, when I hover over an element in the Elements tab, it highlights that element in the browser pane. On the right side of the panel, there are tabs for inspecting the details of the elements further. This panel shows us what CSS is applied to an element and the result of the element displayed in the browser. You will explore these details in a later lesson. For now, you just need to know that if you click on an HTML element, then the information for that element will appear in the tab. Now, I'm going to demonstrate a fun trick. If you double-click the HTML, you can edit it in the web browser. For example, if I select the R menu body element, then I can change the first item in the menu from chicken burger to turkey burger. This doesn't change the content on the web server. It only updates it for me while the web page is open. If I open the web page again, it will reset. The web browser developer tools are a valuable part of your development toolkit to help you investigate and diagnose problems. And you now know how to access and make use of them. Great work.
Tell me what's your flavor? I just spent 2 hours crying, but how could you know that? When all you see is me smiling like I with a coat, yeah. Little things hurt like a giant, little man, I feel like dying, but you know I can't stop trying. I hope you know that. This shit been so fucking crazy, I might bring my fro back. Just cause you posted a picture, it don't make you pro black. Can't you see that I'm just tired? Growing up now, I'm just flying. When I see over horizons, don't make me go back. It's getting hard to hold back. It's getting hard to hold back. It's getting hard to hold back these tears. It's getting hard to
called you on a name that I found the other day. Could you explain? This conversation's getting old, and my thoughts are taking hold. I wouldn't be.
You are developing solutions, but you need to save some time and build faster. What if some of your build problems have already been solved for you? Well, it's true. Someone has already figured out many key development processes, and they're contained in frameworks and libraries that are used every day in software development. So, what exactly are frameworks and libraries? Let's say you are not a developer, but instead you work as a carpenter. You make chairs and sell them online. As a carpenter, you don't design a new hammer for every chair you make. It makes much more sense to use an existing hammer. But of course, you are a developer. As such, it's important for you to know that to speed up development, developers use already developed frameworks and libraries in their application development. These might be open source, meaning that the source code is freely available for anyone to modify and build from. There are thousands of open source libraries and frameworks available, or they might be proprietary, ones that are licensed or developed internally. Many developers use the terms framework and library interchangeably. So, what's the difference between them? Libraries are reusable pieces of code that can be used by your application. They are purpose-built to provide a specific functionality. To give a more technical example, you're building a small e-commerce website. When a user wants to register, they need to provide their email address. Email addresses, while easy to read, can be complicated to validate. In fact, email addresses are defined across several technical specifications. That's a lot of reading just to validate an email. Even if you do read through all the specifications, there's no point in spending hours or even days implementing their standards because you have access to so many readily available libraries to validate email addresses. It is for specific functionality, like validating an email address, that libraries are useful. A developer simply uses the library to access the functionality they require, and as a result, they can have more time to continue focusing on the development of their application. Frameworks, on the other hand, provide a structure for developers to build with. Consider this in the context of our carpenter analogy. As a carpenter, you create a lot of different chairs. Therefore, there would be a blueprint for each chair to speed up building them. You can decide the type of wood to use, but the dimensions and style of the chair are always the same. Frameworks act as a structure where the developer provides their own code that the framework interacts with. For example, there are many frameworks for developing web applications. These frameworks handle functionality that is common to all web applications, such as receiving HTTP requests and sending HTTP responses. The developer then adds their own code that implements the functionality of the web application. For instance, with the e-commerce website example, a framework would handle receiving HTTP requests. The developer would implement code that processes the request and returns the response, from which the framework would send a response over HTTP. Now, let's compare how the frameworks relate to libraries. Most frameworks use many libraries. The libraries that the framework uses can be used by your application. If you wish, your application can also use other libraries. You also need to consider when to use a library. Frameworks are considered opinionated, and libraries are considered unopinionated. This is defined as the degree of freedom available to the developer to choose how to code a feature. The opinionatedness will vary between frameworks, but by definition, they will always be more opinionated than a library. Frameworks define the libraries, flow, and control of an application. Whereas with libraries, those are left to the developer to decide. As with everything, there are advantages and disadvantages to both. Frameworks are a great way to reduce development time and enforce a structure on how code is written. They have many best practices already in place and contain most of what is needed to develop an application. However, sometimes you may find that the way you need to code something doesn't fit into the structure of the framework. Other times, you may find that some of the libraries the framework uses may conflict with a library that you are required to use and cause compatibility issues. If an application is built without a framework, the developer will need to decide on the set of libraries they wish to use to achieve the functionality they must deliver. They will also need to take care that the selected libraries can work together. The upside to this is that they can replace libraries as needed. For example, if a new, better library is released, the developer can replace the usage of the old library. This is much easier than replacing framework. Frameworks and libraries give you the opportunity to reuse existing web app functions. This can result in faster development, fewer errors, and more time for you to spend on the essential features of your application. Instead of reinventing the wheel, you can use frameworks and libraries that are designed specifically to help your web app development processes.
Are y'all good? No, out. Go. Get out. Don't you? What you gonna talk? Who you gonna talk to? I'll fuck you up, dog. Out. Go. Come on. Out. You too. You too. Alright. Time to take a break. Boy. Oh. Start. Okay, cool. Got 5 minutes. Be real good.
without you. Sitting, looking comfortable, thinking there's things I haven't seen. I'll stay over here, cutting up your shirts to wrap my wounds. Tell me what I wanna hear, keep me tied up in your sheets. Just know one day I'll unravel myself. I wouldn't be the same without you. I wouldn't be the same.
Find ourselves alone here, wanting to disappear, change our names, live on the sun, where every sound is clearer, burns a little deeper, and we're close enough, but your lucid touch evaporates. I open up my eyes, wake up dreaming through the days and sleepless nights. Your lucid touch evaporates. I open up my eyes, wake up dreaming through the days and sleepless nights.
Every day, you access information on your phone, like reading the news, purchasing goods and services, or communicating with friends over social media. But how is all this information transferred behind the scenes? Your favorite websites and apps probably use APIs, and as a web developer, you will discover that APIs are developer friendly, easily accessible, and a very valuable and useful development tool. API is the acronym for Application Programming Interface. An API is a set of functions and procedures for creating applications that access the features or data of an operating system, application, or other service. If this still sounds a bit vague, just remember that the term API is intentionally open to many applications and use cases. As a web developer, a lot of the day-to-day job involves working with APIs. Some common APIs that web developers work with include Browser API, REST API, and Sensor-based API. Over the next few minutes, you'll explore each of these API types and review a few specific examples. To begin with, here's a brief outline of how APIs function. In software development, APIs are often the bridge between different components or systems. This earns them names like gateway or middleware. The term is used widely to represent many different tools and systems. Let's consider some examples of different API use cases. One common type of API is browser or web APIs, which are built into the browser itself. They extend the functionality of the browser by adding new services and are designed to simplify complex functions and provide easy syntax for building advanced features. A good example is the DOM API. The DOM API turns the HTML document into a tree of nodes that are represented as JavaScript objects. Another example is the geolocation API that returns coordinates of where the browser is located. There are also other APIs available for fetching data, known as Fetch API, drawing graphics or Canvas API, keeping history or History API, and client-side storage, also known as Web Storage API. Another critical type of API for web development is the RESTful or REST API. This kind of API provides data for popular web and mobile apps. These are also called web servers. Let's explore REST in a bit more detail. REST, or Representational State Transfer, is a set of principles that help build highly efficient APIs. One of the main responsibilities of these kinds of APIs is sending and receiving data to and from a centralized database. We can query our own REST API or third-party ones. One last type of API that you might encounter as a web developer is a sensor-based API. This is what the Internet of Things, also known as IoT, is based on. These are actual physical sensors that are interconnected with each other. The sensors can communicate through API and track and respond to physical data. Some examples are Philips Hue smart lights and NodeBots. That's a lot of API to think about. Fortunately, for web developers, the most common data API is a RESTful API, which, as you've learned, is a web server that provides responses to requests. These API web servers are designed to provide the data backbone for a web client like a web page or mobile app. This means that these APIs must be able to accomplish things like getting data, or get, creating data, also referred to as post, updating data, or put, and deleting data, or delete. APIs use REST principles and good design practices to create discoverable interfaces. This helps us get the exact response expected. But exactly how do they work? Here's a closer description of their activity. These APIs use endpoints to specify how different resources can be accessed. The endpoint is built into the URL when accessing the API. Once the endpoint is hit, the API performs whatever server-side processing is needed to build the response. Two common forms of response are full web pages and a data form based on JavaScript called JSON. In this video, you explored some APIs, and as a web developer, you will frequently work with many different types of APIs. You will often use APIs to extend the abilities of systems or to act as a bridge between different components. Think of a group of construction workers. Every worker has a toolbox that helps them get their job done. As a developer, you'll also use many tools. One of the main tools in your toolbox is the Integrated Development Environment, or IDE. By the end of this video, you'll be able to identify an IDE and explain the benefits of using an IDE during development. An Integrated Development Environment, or IDE, is software for building applications. An IDE is just like a text editor, except instead of writing documents, you're writing code. There are many IDEs available. Some are specific to one programming language, while others support many languages in one IDE. Let's explore some common IDE features. Here I'm working within an IDE. First, let's cover syntax highlighting. To improve readability for developers, IDEs have syntax highlighting. What this means is that special keywords of the programming language are highlighted in different colors so that the developer can quickly differentiate these keywords from other text. For example, if you're writing JavaScript code without syntax highlighting, it could be harder to identify keywords from other text. With syntax highlighting, that gets much easier because the JavaScript keywords and variables are colored differently. Now, let's explore error highlighting. Just like checking spelling in a text document, IDEs can highlight mistakes you make in your programming code. For example, if I delete the equal symbol where it's needed, my IDE will highlight the error. Another feature of IDEs is autocomplete. When you're typing a message on your phone, it suggests words as you type. An IDE's autocomplete is a similar feature. Since programming languages have special keywords, IDEs can offer suggestions to autocomplete words as you start typing them. Additionally, another feature called IntelliSense can make IDEs very smart and even able to understand your code. They can detect variables and functions and offer them as suggestions during autocomplete. For example, if I have a JavaScript function named myFunction defined at the top of a JavaScript file, Then as soon as I start typing the letter M, my IDE suggests this function as an auto-completion. Then there is refactoring. Since IDEs understand your code, they can help you if you need to change it. To demonstrate how refactoring works, let's continue with the myFunction function that I defined a moment ago. In the code, the function is then called multiple times. It can also be called in the code of other files too. But what if you need to rename this function? You would need to rename it in every file that uses the function, ensuring that you update those files to use the new name. This process is known as refactoring, changing the structure of the code without changing the functionality. Doing this manually is very time-consuming and prone to error. If you mistype the new function name in one place, the application will break. Since the IDE understands your code, it can assist with refactoring and automatically update the function name across all files. That saves a lot of time. Let's rename our function now. I just right-click on the function and select Rename Symbol. Then I change it from my function to our function. The IDE then updates all references of that function name. IDEs come with a lot of other features to help investigate bugs and collaborate with other developers. Many even allow you to extend their functionality using plugins and extensions, but that's beyond the scope of this lesson. You have explored some features of IDEs in this video. You now know how IDEs operate as part of a developer's toolbox to write code more effectively. Well done. You've reached the end of this module on web development. Over the course of this module, you've explored the basics of how the web works and familiarized yourself with key concepts in core internet technologies. Let's recap the key skills that you gained along the way. You started the module with an overview of how the web works and explored the basics of web pages, web servers, and web browsers. In terms of web pages, you should now be able to differentiate between a website and a web page by outlining the key elements of each, outline the purpose of HTML and CSS, and provide an explanation of how they work, and identify the benefits that JavaScript provides to a web page, like interactivity and data processing. You've also explored the basics of web servers and should be able to explain how a data center provides storage and power for web servers, differentiate between the key functions of web server hardware and software, and outline how a web server handles requests through HTTP or Hypertext Transfer Protocol. And you explored the third key technology of the web, which is web browsers. Following this exploration, you should now be able to explain what a web browser is, describe how a web browser receives content from a web server and displays it for users, and outline the request response cycle. After your study of how the web works, you investigated core internet technologies. You should now be able to explain the concept of IP addresses and how they facilitate the transfer of data across the internet, demonstrate an understanding of how HTTP functions and identify common HTTP methods, and outline how HTML, CSS, and JavaScript interact with one another to generate web pages. Differentiate between a web page, website, and web app. Identify the front end and back end of a web app, and list common web browser developer tools. And finally, you should be able to demonstrate an understanding of libraries and frameworks, along with their advantages and disadvantages. Identify an application programming interface, or API, and explain how it's utilized in application development, and explain the purpose and benefits of an IDE, or integrated development environment. Now that you have completed this module, you should be able to demonstrate your knowledge of the basic concepts of how the web works, and you've also demonstrated your understanding of core internet technologies. You've made a great start on your learning journey. Excellent work.
Okay. um, hey, let's go.
When a team of builders begin constructing a building, one of their key tasks is to assemble the frame. It doesn't matter what kind of building it is, it always starts with a frame of beams and rafters. Once in place, the frame guides the rest of the construction. If you compare a building with a web page, an HTML document is a lot like the frame. It's a basic structure assembled with different components such as tags and elements. In this video, you will learn about HTML documents and the difference between HTML tags and elements. To begin, let me tell you a short story about where it all started. Sir Tim Berners-Lee, a physicist, often thought about how he and his colleagues from around the world would share information. You were so used to browsing information online that it might seem a silly thing to ponder about. Actually, that question was very relevant at the time and started the development of HTML. Would you like to explore the very first web page? I know just where to find it. The first web page was created in 1989 by Sir Tim Berners-Lee. He worked at the European Organization for Nuclear Research, or CERN, and originally proposed HTML. The first version of HTML was released in 1991, along with the first web browser and web server. HTML stands for Hypertext Markup Language. But what does that mean exactly? Hypertext is text which contains links to other text. Markup refers to tags and elements used within a document. For now, let's just focus on some of the basics of HTML. HTML is simply a text file with a specific structure that consists of elements and tags. Also take note that HTML files usually have a .html suffix. For instance, when you visit a website, the first page that is returned to the browser is often called index.html. Now, let's explore what HTML tags and elements are. Each HTML element consists of an opening tag enclosed in angle brackets. For example, to create a paragraph, you type a left angle bracket, the letter P for paragraph, and then a right angle bracket. Most elements are paired with a closing tag, which has a forward slash after the left angle bracket. For example, you close a paragraph element with a left angle bracket, a forward slash, the letter P, and a right angle bracket. HTML elements usually have some content inside them. For example, between the opening and closing tags of a paragraph, you add the text of the paragraph you want to write. HTML elements can also contain other elements. For example, you can add an italics element inside a paragraph element to make text appear in italics. But elements can also be empty or self-closing, meaning they do not have a closing HTML tag. One example of a self-closing element is the line break tag. You can add a line break tag in a paragraph tag to move content to the following line by typing left angle bracket, the letters BR, then right angle bracket. At the end of a self-closing tag, you simply add a right angle bracket, but you can also close the right angle bracket by typing a forward slash right before it. Now that you know what elements and tags are, you will explore what HTML standards are. The rules and structure for elements and tags are known as the HTML specification. The HTML specification is maintained by the World Wide Web Consortium, or W3C as it is commonly known. Whenever the HTML specification changes, a new version of HTML is standardized. The current version is HTML5. So to summarize, HTML elements with their opening and closing tags in angle brackets build up an HTML document. These elements form the structure of a web page and describe to the web browser what to display. For example, the browser reads an HTML page that has an image tag to display an image file called icon.png. Next, it reads a p tag to display a paragraph under that image. But the browser reads the HTML document and displays the web page to the user in a very basic format. Now, if you want to tell the browser how to display the web page, you should use CSS. You will learn more about CSS in this course. By now, you have learned how HTML tags are used to create elements that build the structure of a web page. You'll have an opportunity to explore HTML in action in this course.
In this video, I will guide you through the blueprint of an HTML document. I will create a very simple web page for a restaurant called Little Lemon. The great thing about HTML documents is that you don't need the web to view them. Yes, they don't have to be hosted on a web server for you to view them in your web browser. You can save HTML files on your computer and view them locally with your web browser, almost like eating takeaways at home. So by the end of this video, you'll be able to identify the structure of an HTML document and create a basic web page. To create an HTML file in Visual Studio Code, I right-click in the Explorer panel and select New File, name it index.html. By now, you know that HTML documents are made up of elements and tags. But before I can add elements or tags, I first need to create the standard HTML structure, which starts with the doctype declaration tag. This notifies the web browser that it is an HTML document. Next, I create the HTML tag, which is also known as the HTML root element. And inside the HTML tag, I add the two main elements, the head and the body elements. It's important to know that nothing inside the head element is displayed as a web page in the web browser. In the head section, you add information or metadata about the HTML document. It is not part of the content of the web page. For example, inside the head tag, you always create the title element. This is the title that is displayed in the web browser tab. I can also link to CSS files and define meta tags in the head section. Meta tags can, for instance, specify the description of the web page, keywords for search engines, and the author of the web page. Next up, I add the content of the web page inside the body tag. The body can contain elements such as headings, paragraphs, images, and videos. Okay, let me start by adding a main heading on the web page by using the h1 tag. Inside the h1 tag, I type the heading Our Menu. That's good. Now I need to start creating my menu. I want to add 2 items, so I add 2 subheadings. For this, I use the h2 tag. The menu items in the subheading are falafel and pasta salad. But first, I need to save the file by pressing the keys Ctrl and S, or if you're on a Mac, Command and S. Now I right-click on the index.html file in the Explorer panel and select Reveal in File Explorer. If you're not using the Windows operating system, this may be called Reveal in Finder or Reveal in File Browser. Now the file browser opens and lists the file. I double-click on the index.html file and it opens in the web browser. Great, it's all here. The title that displays in the browser tab matches the title that. This notifies the web browser that it is an HTML document. Next, I create the HTML tag, which is also known as the HTML root element. And inside the HTML tag, I add the 2 main elements, the head and the body elements. It's important to know that nothing inside the head element is displayed as a web page in the web browser. In the head section, you add information or metadata about the HTML document. It is not part of the content of the web page. For example, inside the head tag, you always create the title element. This is the title that is displayed in the web browser tab. I can also link to CSS files and define meta tags in the head section. Meta tags can, for instance, specify the description of the web page, keywords for search engines, and the author of the web page. Next up, I add the content of the web page inside the body tag. The body can contain elements such as headings, paragraphs, images, and videos. Okay, let me start by adding a main heading on the web page by using the h1 tag. Inside the h1 tag, I type the heading Our Menu. That's good. Now I need to start creating my menu. I want to add 2 items, so I add 2 subheadings. For this, I use the h2 tag. The menu items in the subheading are falafel and pasta salad. But first, I need to save the file by pressing the keys Ctrl and S, or if you're on a Mac, Command and S. Now I right-click on the index.html file in the Explorer panel and select Reveal in File Explorer. If you're not using the Windows operating system, this may be called Reveal in Finder or Reveal in File Browser. Now the file browser opens and lists the file. I double-click on the index.html file and it opens in the web browser. Great, it's all here. The title that displays in the browser tab matches the title that I added to the head section, and the content is displayed in the browser window. But it's still a bit empty. I go back to Visual Studio Code and add a short description for each dish. I do this by adding the paragraph tag below each subheading H2. Let's imagine a nice falafel. I type chickpea, herbs, and spices. What goes in a pasta salad again? Lettuce, vegetables, and mozzarella. Yummy. I save the file to update the changes and open it in my web browser again. There you go. Now the ingredients are also included in the menu. Some of the best websites are websites about food. Whenever you need some inspiration, search for food website ideas online. You'll be fascinated. Now that you know some basic HTML tags, try to identify where they were used in those websites. There are many HTML tags that you can use in your web pages, but you are now familiar with a few elementary ones, and I encourage you to start practicing with them. Best of luck.
All right, let's see, what do we got here? Click on the blue work in browser button above, blah, blah, blah. Okay. Open the README in the preview mode and follow the instructions to view README in the preview mode. Right click README. Okay. Open preview. Okay. Create a valid HTML document that displays a piece of text. Yeah. Boom. Add the text to the body of it. Follow step-by-step instructions below. Boop. All right. Oh, nope. There we go. And we're gonna go Alt Z. Okay. Dun, dun, dun. Bullshit. Okay.
By now, you should know how to build a basic web page. But how do you build a website? Remember, websites consist of multiple web pages linked together. To link pages together, you use the anchor tag. Anchor tags create hyperlinks, or links as they're commonly known. In this video, you will learn how to link different web pages together to create your own website. In my project folder, I now create a second web page for Little Lemon that will contain the address of the restaurant. I right-click in the Explorer panel to create a new file and name it location.html. I use the same file structure created in my index file, but add new content. I add a new h1 tag for the heading and type our location. Next, I add a paragraph tag and insert the address 123 Home Road, Main District, Capital City. I press Ctrl and S to save the file or Command and S on the map. Now that my new file with the restaurant location is created, let's navigate back to index.html file to add a link from there to the location.html file. Below the last paragraph tag, I add the anchor or A tag, followed by the href attribute or hypertext reference. Now I need to specify where the hypertext reference should link to. I type the file name, location.html, so that my index.html file will link to it. Within an A tag, I can also add a descriptive text that is displayed as the link name on my website webpage. So I type our location. The text our location will now display on the webpage in the browser as a clickable link. Let's test if it works. I save the file to update it with the changes and open it in my browser by right-clicking on the index.html and selecting Reveal in File Explorer. If you're not on Windows, this may be called Reveal in Finder or Reveal in File Browser. Then I double-click on the index file. Words our location are displayed in blue in the web browser. Success! If I click on the blue link, the browser opens the location.html file. You can now link different HTML files together to create your website. Best of luck. A picture is worth 1,000 words, as they say. And I think you will agree that a website without pictures wouldn't provide a very good user experience, especially websites about food. My example website about Little Lemon could certainly use a few images. In this video, you will learn how to add images to HTML documents using the image or IMG tag as it is commonly known. I have two image files in my project folder, one named falafel.jpg and another named salad.jpg. Similar to what I did with document links, I have to specify the link to the image file in the image tag. Images are not inserted into web pages. Instead, we use image tags in HTML to link to image files. The image tag then creates a placeholder for the image on the web page. To add the image tag, I type IMG and inside it, I add the src attribute, or source attribute as it is known. After the source attribute, I enter the name of the image file I want to link to. I type falafel.jpg as the source for one image and salad.jpg for the other image. Let's save the file and open it in the web browser. The images are displayed, but they are way too big. Luckily, there are several ways to set the size of an image, but in this video, I will demonstrate how to do this in HTML. Right after the source link in the image tag, you can specify the dimensions of an image. I first add the width attribute and set it to 240 pixels. Then, I add the height attribute and set it to 135 pixels. I'll set the other image to the same dimensions. Let's save and view it in the browser again. Much better. The images are smaller, but there is one important attribute that you should always include with image tags. It is good practice to add a short description for images. It helps to improve accessibility for people using assistive technologies, and it can also improve search engines' rankings. You can add image descriptions with the alternative text attribute, also known as the alt attribute. Still within the image tag, after the dimension attributes, you can add the alt attribute. I will type a short description, a falafel, and for the other image, I will add a pasta salad. I will save the HTML file again and open it in the web browser. The alt text is not displayed anywhere on the site, but will be read by assistive technologies such as a screen reader. Screen readers and other accessibility tools use the alt attribute to provide information to their users. Now you know how to add images to websites with the image tag. The Little Lemon website is now ready for everyone who uses the web. Have fun while you make your sites colourful by adding images. My website for Little Lemon is coming on well, but some key information is still missing: the prices. The best way to add information like a price list is by using an HTML table. You might be familiar with columns and rows in spreadsheet software. HTML tables look similar and allow you to neatly organize content in rows and columns. Websites almost always have information that needs to be organized in a way that makes it quick and easy to read. For example, the schedule of an event, available sizes of clothing items, or the specs of a camera. In this video, I will demonstrate how to create a simple table for the prices of Little Lemon. I want to add the table with the prices to the bottom of the index.html page, so I already have it open. Still within the body element, below the anchor element, I add the table tag. Inside of it, I add 2 table row tags, or TR tags as they are commonly referred to. This will create a row for each of the dishes. Now, I need to add table data tags, or TD tags, so I can include the prices. Table data tags define the contents of table cells, so I need to add 2 of those inside each row, one for the dish name and one for its price. In the first row, I type falafel inside the first table data tag, and in the second table data tag, I add the price. Let's say $10. I do the same with the second row. I type pasta salad inside the first table data tag, and the price of $12 in the second table data tag. Now, I will save the file and open it in my web browser. Great. The prices display at the bottom of the web page. The table is not displayed like a regular table at the moment, but I will style it soon. To make it more clear for my users, I'm going to add headers to the columns now. To do this, I add a new row to the top of the table with the table row tag, and then use the table header tag, or TH tag, for the heading cells. So I need to add 2 table header tags. I type dish in the first column's heading, and price in the second heading. I save the HTML and refresh it again to check the update in the browser. Yes, the page layout is now better. The information is presented much clearer now that the columns have headings, but it is not displayed like a table yet. I will add a bit of CSS to improve the styling of the table. Don't worry about the details of this just yet, but I would like to add a little bit of magic now to get you excited about styling. I will do this by adding a style tag. I will add a 1-pixel border around the table. Let's save the file again and open it in the browser. Now the table has a border around all the cells. This is just a quick method of styling a table. Later, you will learn how to do this using best practices with CSS. Congratulations! You now know how to add tables to HTML files. I use tables extensively, and I'm sure you will too. Today, you can order almost anything directly to your home. But did you know that one of the functionalities that makes online shopping possible is HTML forms? Without them, you would not be able to enter your credit card details during checkout. But forms are not limited to e-commerce. You can use forms practically every day on the internet. When you log into your favorite website, you do it using a form. In this video, I'll take you through the steps to create a form and introduce you to a few different input types. But first, let's briefly explore how forms work. To put it simply, when a user enters data on a website, an HTML form submits an HTTP request containing the data to the server. But how do you create a form in the first place? You define forms with the HTML form tags. Forms also have an optional form attribute called action. Action specifies the URL or path that the form should submit the request to. When the action attribute is not specified, it submits the request to the same path as the current web page. There is also the form method. With the form method, you can specify the HTTP method to use for the HTTP request. There are 2 HTTP methods to submit the form data, get and post. Remember, the get HTTP method retrieves information from the server. The post HTTP method sends data to the server. When a user submits a form, one of these HTTP methods is used. We'll explore how this is done on a later course. Now, let's explore how to add fields that the user can enter data into. First, let's add a simple text field. For example, a username field. The fields in a form are specified by input tags. Note that the input tag does not need a closing tag, but if I want to, I could close the tag by adding a / before the end of the input tag. When I use the text input type, it displays a text field on the web page. But a text box on its own isn't very user-friendly, so I will now add a label above it. By adding the label tag, the form will now display the word username above the input field. Next, let's add a password field. In this case, I won't use the text input type since I don't want the password to be visible. HTML has an input type specific for passwords that will mask the user's input data. The username will be visible and the password will be masked. Finally, I need to add a button so that the user can submit the form. So I use the input type submit. When the user clicks the submit button, the HTTP request containing the form content will be sent to the web server. In summary, you use the form tag at the start of a form, whereafter you indicate the method that should be used. You can create labels for input mark. Don't want the password to be visible. HTML has an input type specific for passwords that will mask the user's input data. The username will be visible and the password will be masked. Finally, I need to add a button so that the user can submit the form. So I use the input type submit. When the user clicks the submit button, the HTTP request containing the form content will be sent to the web server. In summary, you use the form tag at the start of a form, whereafter you indicate the method that should be used. You can create labels for input types with the label tag. You use the text input type for a text input like a username. For a password, you use the password input type. To add a submit button to a form, you use the submit input type. There are many different input types available. For example, you can add checkboxes to a form. To do this, you use the checkbox input type. You use the name and value attributes to configure how the data is sent to the server. Each box can be checked or unchecked. You'll explore this in more depth in a later course. Radio buttons, on the other hand, are like checkboxes, except only one button can be checked in the group. Checking one radio button will uncheck all the other radio buttons. There are also other types of inputs such as the number, email, and file upload types. However, some input fields do not use the input tags. For instance, the multi-line text field. The text input type that I showed you earlier is only for single-line text content.